kiddos. Today we're going to talk about section 5.9, triangle proofs using CPCTC. So if you understood the previous section, we are actually going to only be adding another step or two to these proofs, so they shouldn't really be that bad. Where does CPCTC come from? Today our objective is to use corresponding parts of congruent triangles are congruent. CPCTC, say that 10 times in a row and you will remember it, to prove that parts of triangles are congruent. And again, we're referencing the same few chapters in our book, pages 222 through 250, if you need additional reference. All right, so we have learned how to show two triangles are congruent, and we use things such as side angle side, side side side, angle side angle, etc. Now, what if we want to show that parts, like the sides or the angles of those two triangles, are congruent? What we will do is we will prove the triangles are congruent, just like we did yesterday. So we're going to use side angle side. We're going to use side side side. We're going to use hypotenuse legs, just like we did yesterday. And then we are going to add 1 to 2 additional steps to prove that those additional parts are congruent. The reason for this will be CPCTC. And what does that stand for? It stands for corresponding parts of congruent triangles are congruent. Boom, 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 boom. All right, so there you go. CPCTC. Corresponding parts of congruent triangles are congruent. All right, so there you go. Occasionally we will, I'm going to erase that. Occasionally we will use CPCTC and then have to make an additional statement like AB is parallel to CD. That sometimes happens, but is not always the case. All right, so let's look at some problems. So here we are on example 1. We're given that AB is congruent to CD and that AB is also parallel to CD. So AB is congruent to CD and AB is also parallel to CD. So let's start our proof. Easy part. AB is congruent to CD. So AB is congruent to CD. Beautiful, easy. We have a pair of congruent sides. And that was given to us. Okay, looking at what else I know that AB is parallel to CD. And I also know that that was given to us. So you got to think, when we see the parallel sign as a given in our proofs, we should look for the magic Z. So if I take this picture and I look for the magic Z and I think about where the little armpits of those Z's are, they're right there. So I know that those two angles are congruent. So what that parallel statement is trying to tell me, it is trying to tell me that angle ABD is congruent to angle BDC. And again, long reason, if two lines are parallel, then alternate interior angles are congruent. I'm going to use abbreviations today. Okay, so now I have a pair of congruent angles. Beautiful. Still only 2 things, so I don't have enough yet to prove my triangles are congruent. I know some of you are just shouting at the computer right now, Ms. Schwartz, DB is congruent to DB by the reflexive property. Yes, you are absolutely correct. DB is congruent to DB because of the reflexive property. I don't know what is going on with my writing right now, but whatever. Okay, so here we go, set of congruent sides. This is enough to prove that my triangles are congruent. So I'm going to combine this statement, and this statement to say that my triangles are congruent. And you can continue to go down your page. I just don't have a lot of room going down. So pick an order for your letters for triangle 1. I'm going to use ABD just because that's what I choose. And then remember, when you write the second congruent statement, letter order is important. So take a minute and look at the picture. If I went from A to B and then B to D, what order does my second triangle need to be in? I think it needs to be C, D, B. And I know that those two triangles are congruent from the side angle side property. Now, if you look at what we're actually trying to prove, we're trying to prove that angle A is congruent to C. So now that I have proven my two triangles are congruent, I know that all their parts are congruent. So now I can come in here and I can write one additional step. Again, your step can be below. I just ran out of room, so I'm going to write mine next to it. So my last step will always, always, always match whatever I have in my original problem. So this is going to say that angle A is congruent to angle C, and you will have this memorized. CPCTC. Corresponding parts of congruent triangles are congruent. All right, so that's all it is. The first 5 of those steps are identical to the previous lesson, and we have added that last step for an extra ounce of fun. And that's all you got to do. All right, so next problem. So we are given that AD and DC are congruent, and we're also given that BD is perpendicular to AC. So looking at my statements, I'm going to write the second statement first just to be different. BD is perpendicular to AC. I know that is given. Now, think about this symbol right here. Whoops. Think about, try that again. That symbol right there. That symbol right there is perpendicular. So by definition, what do perpendicular lines do? Okay? Perpendicular lines form right angles. So that tells me that angle DBA and angle BDC are right angles. So again, if I look right here at this symbol, this reason follows directly from that symbol. So this is going to be definition of perpendicular lines. Now, what do I know about all right angles? I know that all right angles are congruent. So I can say that angle DBA is congruent to angle BOC. And that is because all right angles are congruent. So I can come in here, I can look, and I can see that I have right angles here, so this is following from there. All right, so now I have established a pair of congruent angles. Now, you might say, hey, Ms. Schwartz, can we not use hypotenuse leg on this? And then you wouldn't have to do that extra step. Well, to be honest with you, I'm going to come in here in a second and say that BD is congruent to itself by the reflexive property, and I'm going to use side angle side. I have no way of knowing the hypotenuses of those two right triangles are actually congruent, so because I'm using side angle side, I have to have that congruent statement. All right, so now looking up here, I use that piece of information. I know that AD is congruent to DC. And that's right here, my givens, so that is given to me. I just kind of mentioned it about BD. BD is congruent to itself by the reflexive property. So here I have a set of congruent sides. Here I have a set of congruent sides. I literally don't know what I was thinking here. Those are not sides. This is actually a set of congruent angles. And fix that mistake. We're only human. So now I look at the information that I have, and I have this piece of information, this piece of information, and this piece of information, and that is enough to write my triangle congruent statement. So again, letter order is important. So if I go from B to A to D, triangle bad, and now I look at my picture, if I went B to A and then A to D, that means for my second triangle, I need to go from B to C and C to D. I know these two triangles are congruent because of the side angle side postulate, so state my reason. And now, because of the congruent statement, those two triangles are congruent, that means all the parts are congruent. So once we know the triangles are congruent, the remaining sides and remaining angles are congruent. So now I can come in here and say that segment AB is congruent to segment BC, and my reason, CPCTC, corresponding parts of congruent triangles are congruent. And again, whatever you have right here is what's going to go right here. Every single time, no matter what the proof, that will be your last statement. All right, so example 3. You're given that DB is a bisector, and it bisects segment AC, and the DE is parallel to BE. So I really want you to hit pause and rejoin me after you work on this proof. Even if you only get to the triangle congruence, we will do the last 2 steps together. So hit pause and get to work. All right, welcome back. So I did this proof, so take a minute, look it over. You should have used side angle side. So here's side angle side right here. And that's what we used to show that the 2 triangles were congruent. So make sure you have all the steps in check up to this point. And now if I look at what I'm trying to prove that the lines are parallel. Just because you have 2 triangles that are congruent, it does not mean your lines are parallel. But what it means is if we think about parallel, anything parallel, we can think back to that magic Z. And if I could show that angle A and angle C over here are congruent, so if I could show that those 2 are congruent, then I can make the statement that my lines are parallel. So what I'm going to do from here is I'm going to come over here and I'm going to say that angle A is congruent to angle C. And the reason is if is actually CPCTC, how to think, CPCTC. So I know that those 2 angles are congruent because the corresponding parts of congruent triangles are congruent. However, now I'm going to go through and I am going to say, okay, well, you know what? If those angles are congruent, now I can show that AC is parallel to BC. And if I think about how I know that if alternate interior angles are congruent, so if alternate interior angles are congruent, then 2 lines are parallel. So it's the converse of the alternate interior angle theorem. All right, that's all I have for you today. I look forward to seeing you in class tomorrow, and we'll be glad to answer any questions you have, and we will get started on our assignment. Have a great night. Talk to you tomorrow. Bye-bye.